Hello guys, welcome back to another video of E LAGORi. Today let's talk about BLDC motors. It's a peaceful weekend at E LAGORi, spirit of innovation in the air with occasional calls for orders. Good morning Dr. Neutron, we wanted to inquire about our order of BLDC motors. Yes Mr. Ravi, it's as scheduled. Electron, Dr. Neutron's daughter, asks him, Dad, I have read about motors, but what are BLDC motors? Good question, let's get to know BLDC motors. BLDC motor is a type of electric motor. Most electric motors operate through the interaction between the motor's magnetic field and electric current in a wire winding to generate force in the form of torque applied on the motor's shaft. The brushless DC motor, aka BLDC, has a rotor which is a permanent magnet, whereas in brushed DC we have a permanent magnet as a stator. Here we achieve continuous rotation or a rotating magnetic field through regularly switching current in the stator with only two poles active at a time. Since you don't have parts in contact, BLDC lasts longer with less wear and tear. Also, BLDC motors are way more efficient. Driving a BLDC motor requires knowing the position of the rotor at any point in time so that we can determine which coils to excite next to induce rotation. In order to achieve this, several methods are used. One method used exclusively for high torque, low speed motors is to use Hall effect sensors which are placed at 120-degree offset. When the north pole of the magnet is aligned with the sensor, it gives a high signal, and in all other cases it gives a low signal. Using 3 of these Hall effect sensors, we can create 6 sectors, and position of rotor within these sectors can be identified. The E LAGORi board is capable of accepting the readings from the Hall effect sensors and passing it on to the microprocessor so that appropriate action could be taken for switching the coils. So let's see how to interface the BLDC motor using E LAGORi boards. From the block diagram, we can see that the processor board receives the data from Hall effect sensors. After processing the data to calculate the coil that should be next excited, the data is sent to 3 half-bridge networks. The data or power is then sent to the respective coil and motion is initiated. This process is continuous and goes on in cycles, enabling the rotatory motion of the BLDC motor. Following boards are required for the project: the power supply board, ESP32. The connections are made through conductive ink pen. BLDC motor driver. Connections are made as shown. Here is the stack up of the boards. The following video shows the implementation of BLDC motor using E LAGORi boards. So We have built the theory as we said above. Looks cool, right? Let us know if you have any doubts or suggestions in the comment section. Thank you for watching the video.
Visit www.e-lagori.com for more details.